Okay, welcome to my physics class. With me here, your teacher, Mr. A+. Today we are still looking at radioactive decay. Remember, in our previous lesson, we are looking at alpha decay. Today, we are going to beta decay. Okay, from there, then you go to the last type of decay, which is gamma radiation. So beta decay, first of all, before we go to beta decay, the general formula for alpha decay is XA, which is representing the mass number, then Z atomic number. So what normally happens here is that under alpha decay, it is giving out the mass number, how many? 4. Okay, so 4 there is given out. Then here, electrons, number of atoms, 2 is given out. And the final one will be helium, which will remain in 4, then 2. Okay, that is for general formula under alpha decay. So now quickly, let's continue now on beta decay for today's lesson. Beta decay involves the emission of beta particle from the nucleus of a radioactive element. Okay, just one and the same. So now, for example, when radium, even under beta decay, we are giving example of radium because radium is the radioactive element. No wonder why we are using it frequently. Okay, so now, when radium undergoes beta decay, what happens? It emits one electron. Remember when we are looking at the characteristics in the previous lesson, those who are following me, we said what it is for beta particle, it actually gives one electron. Okay, so there we are saying it emits one electron. Therefore, the mass number does not change, but the atomic number increases from 88 to 89 because this one is a negative charged by 1. Okay, which is -1. So therefore it will give out, and from 88, which is the atomic number for radium, will now increase to 89 because one neutron changes to a proton. Okay, that's the main reason why it has changed. Okay, so now after beta decay, radium changes to actinium. Okay, so after beta decay, the radium changes to actinium. But remember, when you are looking at alpha decay, the radium changes to radon. Okay, so this one now it changes to actinium, and the actinium we are even given the chemical formula there, so which is represented by this symbol AC. Okay, so when you happen to look for that one on the periodic table, it will be indicated by letter AC. Now the following image shows the beta decay of radium. So parental nuclide as usual, we have this is parental nuclide, so we have 226, then 88. Okay, then daughter nuclide, this one will still remain 226, but for atomic number it will increase to what? 89. And when the atomic number becomes 89, despite having the same number of mass, we still now the element will change to actinium. Okay, so this is the one. Then plus, what are we going to have now? What we have given out is one what? Electron, which is beta particle. That is the beta particle given. Okay, so now the general formula for this information is also given here, which is A representing mass number, Z representing atomic number. Then here we are saying A will maintain, which is the mass number, but for atomic number, 1 will be added. Okay, the reason is very simple because one neutron changes to proton, so no wonder why it has increased. Then plus C, we are going to have electron, which is the charge 1, but mass number there will be 0. Why? Because it will remain the same. So this is about beta particle. So that's I mean beta decay. So that's the difference which is between the 3 types of decay that we have. So quickly we can go now to gamma radiation, or which is or Y-ray. Okay. So this type of decay involves a nucleus change from a high energy state to a lower energy state. So it's about energy state this time around when you are talking about gamma. Okay, it's a change, involves nucleus change from a high energy state to lower energy state. So now that is through the emission of electromagnetic radiation known as gamma ray. So it's the one that gives out, okay, the electromagnetic radiation known as gamma ray. So it often takes place after alpha decay or beta decay. So this one follows after these two types of decay has taken place. Either one of those two types of decay, which is beta and alpha, when they have taken place, that's when this one also comes in. So it often takes place after beta decay or alpha decay, or has occurred. So now the atomic number and the mass number do not change because it's a gamma ray. This is a radiation that given out or given off. Therefore, the parent element is the same as the daughter element here. Nothing changes. It's different from these two. Then gamma radiation, the most dangerous radiation. Okay, of the three types of radiations, gamma is the most dangerous one. That one damages things. Okay. Then the following image shows the radioactive decay of thorium. Okay, thorium, that one is one of the radioactive decay or element. Thorium emitting a gamma ray. So let us see how thorium emitting the gamma ray. High energy parent nuclei. This is now high energy parent nuclei. So thorium, the mass number for thorium is 234, then the atomic number is 90. Okay, then this one will still remain the same because what has just been given out is the gamma ray, which is the radiation. Okay, to low energy daughter nuclei. This is low now. So no wonder why the energy now level is not shown here because it's low. Then plus what will happen is Y ray, just Y ray. So for Y ray there, mass number you are going to have 0. That one also 0 because nothing has given off or sent out. Okay, so that is how gamma radiation type of decay also is being occurred. Then apart from that, we can also look at the general formula for gamma ray. So general formula, I've put it here. Okay, it's here. This is the general formula for gamma ray. So as usual, A is representing mass number, Z atomic number, so is equals to, is to remain the same. Then from there plus Y ray, that is the one that has been given out. Gamma ray or Y ray. So they're just one and the same. So gamma ray and Y ray, we are talking about the same thing. So thank you so very much for your attention. Please subscribe to my YouTube channel for more exclusive videos and follow me on our Facebook page, Mr. A+. See you in the next class.